Hello, and in this video we're going to end this section with using another division process, not long division, but something we call synthetic division to factor a polynomial. We're going to look at two examples. In this first example, this is the division that you would see here. X cubed minus 24x squared plus 192x minus 512 divided by the binomial x minus 8. Now, that can also be written as a problem that has a root of 8. So c equals 8 means that the root is 8. That means this value here, x minus 8, would equal 0 when x equals 8. So 8 is our root. They just give it to you as a c value, not as an x value. So if you have a root, then you would also write the binomial as x minus 8. In order for this x equals 8 or this x minus 8 to go into this, to be a root means that it would have to divide in evenly. So we're going to have to check to make sure it is a root first. They may have given us a value that might not be a root. Usually we would check it by plugging it in. If we plug in 8 into this equation, you should get 0. So if we plug in 8, that's a quick way to check to see if it's a root. So if we know that they were dividing by x minus 8, we might try 8 into this polynomial function. We just check 8 cubed minus 24 times 8 squared plus 192 times 8 minus 512. And that should equal 0. If that equals 0, then we would have a root at 8, and this x minus 8 would go into it evenly. So we would check that. So in doing that, we would use our calculator, and we get 512 here. We get 15, negative 15 is 36 here. We get positive 1536 for 192 times 8, and we get minus 512 here. And we can see here that these are opposites, so they drop out. These are opposites, so they drop out. So this is 0. So 8 is a root of this problem. Now that means that this x minus 8 will divide into an evenly. And we could do long division to get that to work out, but what we're going to do is do a process what we call synthetic division, because it's quicker and it uses less room. So what we do is we take our root, our 8 root, we put it in a little box out here, 8, and then we write the coefficients of the coefficients of the problem that we're dividing into out here. Now we want to write all the coefficients here. So x cubed, the coefficient is a 1 here, so we'd write the 1 as a coefficient of x cubed. Squared is negative 24 as its coefficient. X is 192 as its coefficient, and 512 is the last constant coefficient. Alright, the rule is that we need to leave a space to do a subtraction. We're going to subtract off every time. In long division we had many lines of subtraction to subtract off, but we only need one in synthetic division because we're going to just move over and subtract as we go. First thing we do is bring this first number down. We put it right here. So whatever this number is in the first thing comes down below the line. We multiply here, multiply here, and we put the answer over here. So 8 is our answer. 1 times 8 is 8. We add these together and we get negative 16. And we would write that right here, negative 16. Okay, we still multiply, so everything down below here is going to be multiplied, so we're going to multiply again. We go over here and we're multiplying here, and we're putting the answer right there. So 16 times 8 is negative 128. We write that there. We subtract 120, we add these together, okay, which is really subtraction. We get 64. And then on the last step, we do that same thing here. We multiply here, we go across and we multiply here. We write our answer right there. That's going to be 512, and that's going to equal 0. So that means it is a root. This is our root here. So this generates a polynomial answer right here. These are the coefficients of the answer that we would get when we divided by x minus 8. So the coefficients are 1, negative 16, and 64. And we go backwards. This is a constant. Then this would be an x, and this would be an x squared going up. So we go backwards here. I can write this as the constant. This would be the x, and this would be the x squared. So this is our factor when we divide by x minus 8. So far we have it factored into x squared minus 16x plus 64 times x minus 8. That's going to equal this x cubed minus 24x squared plus 192x minus 512. So right now we've factored into this. Now what we have is we have a quadratic. We can then factor again. So to get our factored form here, we take our quadratic right here and we'd factor again. So this one would factor again, x and x. We try factoring. If it doesn't factor, we'd use a quadratic formula. But if it says it has factors, they're going to probably give you something that will factor in the end. So factors of 64 that add up to 16, that would be the same as 8 and 8. That's the same thing, 8 and 8. And they're both negative. So that means this has 3 of the same factors. So if we multiply this all out, the 3 same factors, we get this solution. That means the only root of this problem is x equals 8, and it has a multiplicity of 3. So this is telling me if I were to graph this thing, it's got a, if I graph f of x equals this, it's going to look like it's an x cubed. So the graph is going to look like, and it's going to cross through 8. So over here at 8, it's going to cross there, but it's the same 8 every time. So that means it's going to cross, not bounce off. It doesn't bounce off, it crosses. It's positive, so that means it's going to look something like this, because it's got a cubic one. It's going to look like this. It's only going to cross there. It's not going to turn back and go any other way because it has the same root. So this root happens 3 times. So that's kind of what it looks like if we're doing this, because it's positive and increasing. All right, let's do the second example of a similar problem. So if we have this one, this is 2x cubed minus 3x squared minus 11x plus 6 divided by 2x minus 1. That means the root, if we take a look at this, the root is 2x minus 1 equals 0. So that means 2x equals 1. And x is 1/2. So they could write it like this as well, with that being a root of this. So we're going to check to see if it is a root. First of all, let's check to see if it is a root. If it's not a root, then dividing it won't help us factor. So let's check to see if it's a root. 2 times 1/2 to the third power minus 3 times 1/2 to the second power minus 11 times 1/2 plus 6 should equal 0. It's supposed to equal 0. Should equal 0. If it doesn't, then it's not a root, and then we have a problem. They didn't give us the correct problem then. Okay, so we're going to have 2 times 1 over 2 times 2 times 2 is 8. 1 times 1 times 1 is 1 minus 3 times 1/2 times 1/2, which is 1/4, minus 11 halves plus 6. Okay, so this is 2/8, which is 1/4. This is 3/4. 3 times 1, this is over 1, so it's 3/4 minus 11/2 plus 6. Okay, 1/4 minus 3/4 is going to be negative 1/2 minus 11/2 plus 6. So these two are going to be minus 12/2 plus 6. And that's negative 6, so that's going to equal 0 for sure. Okay, so we know it's a root. So we know when we divide, we should get 0. All right, so let's do that. Now, this one's built for long division because it has this thing here. But we're going to do synthetic division again. But we may have to deal with fractions. So let's be prepared for that. So we're going to have to put on our box our 1/2. We're going to get our coefficients of 2 for the x cubes, negative 3 for the x squareds, and 11 for the x's, negative 11, and 6. Now, if there was a missing term, if there were no x squareds here, what you would do is make sure you put a 0 right here. You would hold the place value by placing a 0 in the x squared. So every power of x should have a coefficient. So if you had 0x squared, you'd still put a 0 here. So you need to make sure you do that when you're working on synthetic division. All right, so let's draw our line. We bring down our first number. Okay, remember what we do here. I'm drawing the line here. What do? We multiply here. Okay, multiply 1/2 times 2. That's going to be 1. Put the answer right there. We're going to add. So this is add across here on this row. So we're going to get negative 2 here. Okay, go to the next color. Multiply again. It's going to be negative 1. Add. We get negative 12. And then we multiply again. Different color. Multiply again. We get 6. Negative 6. So we get 0 here. So that's good. So our coefficients of our solutions are 2, negative 2, and negative 12. This is our constant. We're going to put an x here, and they increase by x value. So this is x, and this is x squared. So this is what we would get. It would be factored. We already know the other factor is 2x minus 1. From above, that's the one we had right here that we divided by. 2x minus 1, or our root of 1/2. So this is our factored form up to this point. We would then factor this. This looks like it's an even one. It's got all evens in it. So I would take out a 2, put it in front, x squared minus x minus 6 minus x squared minus x minus 6. And then by 2x minus 1. So then this factors again. This does not, because we already factored it. This does not, it already factored. Okay, so this factors into x and x for x squared. And then 6, negative 6, so one of them is negative and one of them is positive to get negative 6. And they have to add up to a negative 1. So 1 and 6 don't add up to negative 1 or negative 6 and 1. Then, so it's 2 and 3. So 2 has to go here because it's positive, and 3 has to go here negative because negative 3 plus 2 is negative 1. That's this answer. All right, so that means my zeros or roots of this are 3. Because 3 minus 3 is 0. Negative 2. From negative 2 plus 2 is 0. And this one we had was 1/2 from the one that was given. And this doesn't give us a root because it's already a constant. So that means the graph of this, see, is it positive or negative? Let's look back up again. So the graph of this thing right here, without the division, the graph of that would look something like, see, it has a root at 3, so it crosses here, 1, 2, 3, it crosses right here. It crosses here at -2, at 3, and at 1/2. 1/2. So those where they cross, they have multiplicity 1 each because they only have one of them each. One of those things. So what I'm doing is I'm graphing this equation, not the denominator, but just the equation 2x cubed minus 3x squared plus minus 11x plus 6. So it's increasing because it's positive 2x squared. So it's going to go up here, cross through here, come back down through here, cross through there, and then go back up here, cross through there. So it'll look something like this. I don't know what the y-axis is, don't know how high or low it goes here, but I know it does cross at those 3 places. Now I could tell you what this graph is, but that point is y-intercept should be the last value. So the last value here is positive 6. So it does cross at, so mine's a little off here. This should cross at positive 6 right here. So this answer right here is positive 6. So I'm a little skewed here. It should be way up here where it crosses. And then comes back down. Because of the 6 as a constant. Alright, so that's how we find all the roots when dividing, and how to use synthetic division or long division. You can do long division on this. We could practice that as well to get this to work out. So let's do that. Let's do one more practice before we quit this video. We're going to practice long division again on this problem. So we have 2x. We should get the same answer, 2x minus 1 divided into 2x squared, 2x cubed minus 3x squared, 2x cubed minus 3x squared minus 11x plus 6. I believe is our problem. Let's just make sure I got it right. 2x cubed minus plus. Okay, so we're going to do this long division, and we should end up with this solution right here in our division. We should end up with that solution. That solution should be the same solution as we're going to get in this long division problem right here. Okay, now remember long division. We have to do this term into this term first. We need to divide. So that is, I go over here to the side and go 2x cubed divided by 2x. That's going to reduce down to 1x squared. So we're going to put x squared here. That's what that reduces to. So that's our first term. Now we multiply this way to get the numbers down here. So that's going to give us 2x cubed because that was our goal. That times that is 2x cubed. This one times -1 is minus x squared, and we put it right under the x squareds. We then subtract, just like we did in the past. We subtracted this. This goes away. This becomes plus. So we're going to get -2x squared. Bring down everything else, because this is what's left over after dividing by x squared. Now we have to keep going. We have to divide this. Now we're going to do that one next. So we got a 2x squared negative. That's this term. We're dividing it by 2x. We're going to get negative x right there. So that's what's going to be next. Negative x. Right? All right, we do that division, this, and then we multiply this way, and we get -2x squared plus x, and we subtract. All right, change colors. Now this is going to drop out. This is changed to minus. We're going to subtract, so this is minus 12x plus 6. So we're changing this color, and we divide that minus 12x by the first one here, 2x. And we're going to get -6. So this is what goes here, -6. And then if we multiply -6 times that, we get -12x. And we get +6. And we subtract, and we get 0 here. So this is our factor, and we got that right here. See, it's right here. It's actually this factor right here. It's the same factor. X squared minus x minus 6. We got that factor in this one. Okay. We had that factor. All right, and so this factor and that factor give you the same solutions. If we factor this one or we factor that one, we get our same two zeros. Okay. So our zeros are exactly the same no matter what we do here. We did come up with a little bit different thing here. So we had x squared minus 6 minus x minus 6, and then on this one up here we had 2x squared minus 2x minus 12. So when we did synthetic division, we came up with a slightly different solution than when we did long division, but we came up with the same factors. They come out to be the same. The only thing different was the constant term. Constant came out different, but the constant doesn't affect our zeros.